Let's look at how to make the fields for a 3D breast tangent. First, make sure you're in the right workspace. So I'm in External Beam Planning. Next, I'm going to go to Insert, New Plan. I'll select the appropriate course, so C2, and then Next. And I'll label this plan Breast Tang for Breast Tangent, and then say OK. Next, I'll select the appropriate machine, and then go to the Geometry tab and select Static. So this will be an open field. And we'll select the appropriate energy. So for this patient, we will select 6x. In the Prescription tab, I'll enter the prescription, which is 180 and 28 fractions. And then in the Field tab, I'm going to select the name, which will be Left Medial Tang, for left medial tangent. Next, I will right mouse, move viewing planes to the isocenter, and then I right mouse on the field, and I will align the field to the viewing planes. So this puts my field right at the center of the isocenter. And now I can angle the gantry to align with the pink rectangle contour. So I selected 305 as my gantry angle. And now let's look at a beam's eye view. So I'll go ahead and scroll out so we can see the whole field. And I'm going to turn the border contours on. And I want the Y2 and the Y1 field borders to be at the edge of the border contours. And I want at least 2 cm of skin flash. So let me go ahead and open the XJaw here. And next I need to create a DRR. And in this DRR I'm going to use the default breast DRR. And I want to make sure that I can see the wires on the skin surface. So I'm going to go ahead and adjust the window level so that I can see the wires better. So I think I can see them a bit better now. Let me adjust this window level a little bit more. And now I'll right mouse on the field. Before I do that, you can see the wires here. I'm going to right mouse on the field, add MLCs, and then I'll go to the Shaper tool on the MLCs, and I can hand draw this field right along the wire contour, which is running essentially right underneath my graticule. And then I will outline the field borders here with my block. And this defines my aperture. And next I need to move in my X1 jaw to be really close to these MLCs. There's no need to have that collimator left open. So let's see how this looks. Let's go ahead and turn on the MLCs. And you can see that the X1 jaw lines up very nice and tight to the MLCs. So this looks very good. My next step is to go ahead and create a new opposing field. So I right mouse on that field, new opposing field. And this created my left lateral tangent field. And this is essentially just an opposing field from the medial. Now I'm going to insert a new reference point and location. What I need to do here is add a weight point that's at least 2 cm from the isocenter. So right now the isocenter is sitting underneath the block edge. So I'll call this tangent weight point, and I'll select PTV boost as my target volume. And I essentially want this point to be on the same slice as my isocenter. So you can see we're sitting at the same slice as the isocenter, and I'm parallel with the isocenter, but I want the weight point to be at least 1 cm from the lung interface. So I'll move this up a little bit more. And this is essentially where we're going to prescribe dose. So it's parallel with the isocenter and 1 cm from the lung interface. Next, I want to make sure that the tangent weight point is at least 2 cm from the block edge. So I'll look at this both on the medial and the lateral fields. We don't want the weight point to be sitting within the penumbra region, so we need at least 2 cm from the block edge. We'll go to the prescription tab, select the correct reference point, and then we'll go to plan normalization and select reference point to prescribe the dose to. So now both of my fields will prescribe dose to the tangent weight point. Calculate these fields. Right now they're equally weighted. And now let's go ahead and look at the dose distribution. Let me zoom up this axial view. And you can see essentially 100% of the dose is going right to that weight point, because that's how we prescribe these fields. And we have essentially even dose distribution. So we don't have to change the weighting on our tangent fields. They look fairly equal in weighting. And this concludes how to build fields and calculate the fields for a 3D breast plan.